The next functional group, the next homologous series that we'll see is the aldehydes. So aldehydes is the class of compound and carbonyl is the name of the functional group. So when you have the C double bond O, that's the functional group, and there's aldehydes and ketones that have that same carbonyl functional group, C double bond O. And for aldehydes, you will have a C double bond O bonded to an H and then bonded to an alkyl chain. So this alkyl chain can be anything. It could be an alkyl, it could also be an aryl as well. So for example, you could have CH3, and then this is bonded to COH. So as soon as you see COH, this is an aldehyde, and we write it like this. Normally we write CHO. We don't write COH. We write CHO. Okay? This is particular for aldehydes. So let's see aldehydes with one carbon. So one carbon, so you'll have only COH, and then this is going to be an H because we can't have another carbon. So this is going to be called methanal. So all aldehydes, they end with anal. So methanal. Structural formula, so HCHO. So you see the CHO here? And the skeletal formula, I have only one carbon, so only one dot, and this is bonded to a double bond O. So in skeletal formula, we don't show H. So you can just have it like this. Okay, so two carbons, so I have one carbon, double bond OH, and then the second carbon, that's going to be a CH3. So two carbons, this is ethanal. Okay, and the structural formula, so CH3, CHO. And the skeletal formula, so I have a CH3 here, and then a C, this is bonded to the O. So like this. Okay, so you can draw it like this, or you can also draw it like this. This is also ethanal. As long as you have two carbons here, and one carbon is bonded to the double bond O. We don't show H in skeletal formula. So three carbons, propanal, so 1, 2, 3 carbons, CH3, CH2, CHO, and you have one carbon, two carbon, three carbon. So these are bonded, and then this will have the double bond O. So 1, 2, 3 here. And you could also show it like that. So here, that's also possible. 4 carbons, so it will be called butanal. 5 carbons will be called pentanal. So here's the completed table. So just be careful when you're drawing the skeletal formula. So 4 carbons, 1, 2, 3, 4. 5 carbons, 1, 2, 3, 4, 5. Ketones is the other carbonyl compound, and ketones, the difference between aldehydes and ketone is that in aldehydes you have an H and an R, but in ketones you have both being an alkyl chain. So the carbon is bonded to two alkyl chains. So you'll have CO, R, and R in a ketone. So in an aldehyde you have an H. In a ketone, you're going to have CO, R, and R dash, because the R can be the same group or they can be different groups. But it should not be H. So R or R dash should not be equal to H. Then it will be an aldehyde. So this is called a ketone. It ends with -one. So definitely you cannot have a ketone with just one carbon, nor with 2 carbon, because actually, so this is a carbon, this will have to be a carbon, and this will have to be a carbon. So the first member is actually propanone. So you will have 1, 2, 3. So this is the CO, and then carbon, and then this is going to be CH3, and then the other one as well is CH3. So when you're drawing the skeletal formula, so 1, 2, 3 carbons bonded, and then double bond O here. So 4 carbon butanon here. So I have the 4 carbons. You can choose to put the double bond here, or you can choose to put it here. It doesn't really make a difference. It will still be the same, because on one side you will have CH3 and on the other side you will have C2H5. So here is the skeletal formula for butanon. For 5 carbon, so that would be pentanon normally, but let's draw it. So 5 carbons. Now there's several positions where you can put the double bond. You can put it here, or it could go here where both alkyl chains would be the same, or you could put it here. So whether you put it at this position or in this position, it's the same molecule. Okay, so because on one side you'll have 3 carbons and on the other side you will have 1 carbon, so it's still the same. So let's go for this one. Now, because on this one, let's number this. So 1, 2, 3, 4, 5. So this is going to be pentan. There's 2 ways you can name that. Either pentan 2-on or 2-pentanon. It's the same thing. So 2-pentanon, because the double bond is on the second carbon, or you could name that pentan 2-on. Okay, and so drawing that, you will have your double bond O. So 1 carbon on one side and then 3 carbons on the other side. So 1, 2, 3. So 3 carbons, a total of 5 carbons. Now this one is still another molecule with 5 carbons, so it's still another pentanon, but here you can see that the double bond O is on the 3rd carbon. So if you count this, so 1, 2, 3, 4, 5, so it's on the 3rd carbon. Either way, whether you count start from the left or from the right, so either you count 1, 2, 3, 4, 5, so it's still on the 3rd carbon. So this is going to be 3-pentanon or pentan 3-on. So that's the skeletal formula. So 1, 2, 3, 4, 5 carbons. The functional group is on the 3rd carbon, so 3-pentanon.